Hello, Lesson 8, Organics Composite Materials. This chapter deals with composite materials, an area of growing importance. This chapter opens with considerations of material selection, illustrating the fact that single natural and man-made materials are not always capable of meeting our design requirements in some situation, and therefore opening the way for composites to be used. Composites made for reasons of strength and thermal insulation will be considered here, and the various types and geometries of composites are set out. After looking at the composites used in construction, the theory of composites made for strength purposes is set out. This is limited to the use of unidirectional continuous fibers. However, this theory is very useful in many situations. The theory of composites made for reasons of thermal insulation is then set out, and its application to building wall structures is outlined. Composite materials. This is example, and through the ages, men have become more innovative in discovering new materials. Cost reduction techniques adding life to exist far more better. We have seen that man has perhaps 40,000, 80,000 different materials at his disposal. This number includes all the poor metals and alloys, synthetic polymers, bituminous material, glasses, ceramics, fired clay products, etc., as well as naturally occurring materials such as timber, leather, bone, natural stone, etc. It also includes composite materials such as glass, reinforced plastic, and other. This raises a number of questions. In any given design situation, how can we make rational choices when faced with such an large number of materials? What are composites and why are they made? How do composites work and other? Faced with such a large number of available material, at first sight it may seem strange that we resort to the manufacture and use of composites, but as we shall see, it meeting the increasingly stringent demands posed by some design situation. None of the high number of single materials always has the particular combination of properties needed to meet our requirements. We shall therefore pick up the theme of material selection first broached in chapter 1, where it was pointed out that the selection of materials was really the selection of the properties that we require. And now What is the composite material? Often shortened to composites or called composition materials, are engineered or naturally occurring materials made from two or more constituent materials with significantly different physical or chemical properties, which remain separate and distinct at the macroscopic or microscopic scale within the finished structure. Two materials in which one of the materials called the reinforcing phase is in the form of fibers, sheets, or particles, and is embedded in the other materials called the matrix phase. The reinforcing materials and the matrix materials can be metal, ceramic, or polymer. Composites are used because overall properties of the composites are superior to those of the individual components. Composition of composites. Fiber reinforced polymer. FRP reinforcements are shaped either into composite laminates for epoxy bonding onto the masonry surface or into textile fabrics for laying onto the masonry surface and then impregnating the fibers with the matrix. So, what is the FRP? This is a composite that creates a material with attributes superior to either component alone. Fiber or filament reinforcement provide strength and stiffness, high strength and stiffness, and low density. Fiber can be carbon, glass, aramid, etc. Matrix protects and transferred load between fibers. Has good shear properties and low density. Matrix can be from epoxy, polyester, vinyl ester, etc. Fiber reinforced polymer consists of fibers, carbon, aramid, or glass, bonded together with a polymer matrix, epoxy, polyester, or vinyl ester. The necessity of using FRP for strengthening building and structure is due to the internal properties of the material, such as a high strength to weight ratio, corrosion resistance. In addition, both the material and the geometric properties can be adapted for a specific application. Several materials are available for the fibers, that is glass, aramid, carbon. Therefore, fiber reinforced polymer with carbon fibers is abbreviation as carbon fiber reinforced polymer. So, composite. This is a material with attributes superior to either component alone. High strength, high stiffness, good shear properties, and low density. Bottle and dope is one of the oldest man-made composite materials, at over 6,000 years old. Concrete is also a composite material and is used more than any other man-made material in the world. About 7.5 billion cubic meters of concrete are made each year, more than 1 cubic meter for every person on Earth. Composites in industry. Engineering application in aerospace, automobile, pressure vessel, pipes, etc. Any place where high-performance materials are desired. Turret shield, industrial spring, medical table, bulletproof shields, and other applications. Common composite materials. This is a lightweight honeycomb structures and fiber composite components. And typical engineered composite materials include asphalt, fiberglass, cement, plywood, metal matrix composites, ceramic matrix composites, reinforced plastics such as fiber-reinforced polymer or fiberglass, composite wood such as plywood, masonry, etc. The example given above of composite materials combining high stiffness and low density is a composite made for reasons of mechanical properties. Many composites are made in order to achieve a particular and desirable set of mechanical or structural properties. This is, however, not the only type of composite. We can make composites for optical, thermal, and electrical reasons. 2. The manufacturers of cameras and optical instruments make composite lenses from 2 or more types of glass to achieve lenses free from chromatic dispersion and achromatic duplets. For example, electrical cable is a composite. Sheathing and conductors made for reasons of insulating electric current from the structures through which the cables pass or to which the cables are fastened. Similarly, in construction, we use composite blocks to obtain a mixture of compressive strength and thermal insulation. Some purists would argue that metal alloys could be seen as composite materials, but such as argument assumes familiarity with phase, equilibria, and the theory of solute hardening, etc., beyond the needs of civil engineers and construction professionals. In practice, composite very useful for reasons of strength and thermal insulation. So, from the point of view of construction professionals, we can classify composite materials as shown in this table, broad classification of composite materials. The table gives an example of naturally occurring composites, and timber has, of course, been considered in this text. Timber is an example where fibrous reinforcement is used. Most of the vessel cells run in the longitudinal direction. Some proportion less than 10% run in the radial direction. These fibers give the timber its well-known anisotropy. The properties along the grain are very different from those across the grain. This is something that we are all familiar with. We shall examine the reasons and the theory behind this later. In our discussions so far, we have looked mainly at composites made for reasons of strength and examples where the second materials is present as fiber aligned mainly in one direction. There are many other arrangements. The second material can be in the form of short fiber randomly arranged, in the form of particulate spheres, plates, ellipsoids, etc. in the matrix, as lamellar structure alternate layer of the materials, or as skeletal or interpenetrating networks. To give a well-known example, plain concrete is itself a composite. Particles of aggregate reinforce a cement matrix. Reinforced concrete is a composite with steel reinforcement bars aligned in the direction in which the tensile loading is to be carried. Plywood and glue-lame beams are examples of lamellar composites used in construction. Examples of different composites geometries will be discussed next. So, composite type, natural composite materials and macro composites engineering products. Natural composite materials include wood, compact bone and cancellous bone, bamboo, muscle and other tissue. Examples of macro composites are reinforced concrete beams, galvanized steel, helicopter rotor blades, wire-wound pressure vessels and gun barrels, insulated building blocks, etc. Advantages: high strength to weight ratio, low density high tensile strength or high specific strength ratio, high creep resistance, high tensile strength at elevated temperatures, better than steel or aluminium in applications where cyclic loads are encountered, leading to potential fatigue failure, such as helicopter blades. Height resistant to vibration, corrosion resistance. Dimensional changes due to temp changes can be much less. anisotropic. Bidirectional properties can be designed advantage, that is helicopter blades. And of course, advantages of the composite materials is the ease of installation and low diet weight. Composite benefits. Ceramic matrix composite increased toughness, force from band displacement. You can see that unreinforcement and particle reinforcement has different forces, and ceramic matrix composite increased toughness. Polymer matrix composites increased Young modulus divided by density. So you can see Young modulus for polymer from density, Young modulus of polymer matrix composites from density, and ceramics and metal alloys. And metal matrix composites increased creep resistance. This is strain and stress. These are properties of different materials adapted from near creep rupture of a silicon carbide reinforced aluminum composite. Disadvantages or limitations. Materials costs. Fabrication or manufacturing difficulties. Repair can be difficult. Wide range of variability. Statistical spread. Properties non-isotopic makes design difficult. Inspection and testing typically more complex. And in addition to the head cost of the reinforcement elements themselves, this is the need for their protection from fire. The fact is that the glass transition temperature of epoxy glue is only 60 degrees of Celsius, even in the case of the best epoxies. Therefore, it's necessary to very carefully prepare the concrete surface to ensure reliable bonding, and this is the routine work that must be carried before strengthening, and also issues of reliability of alternative method for strengthening building structures by fiber reinforced polymer materials have yet to be properly defined.